Hope you had a good day. We are in Volume 2, Chapter 5, Plant Maintenance. This is something that's kind of near to me. I like to do maintenance. It's mainly what I do. I'm not much of a lab guy, even though I can do lab. I work uh, predominantly maintenance. I enjoy electricity, also work in the collection system and the stormwater system. So my heart's kind of in the outdoor work, but when we talk about wastewater infrastructure, we're talking about the collection system and or the wastewater treatment facility. So there is a lot of work that can be done out in both. We can be working on manholes one day out in the collection system, drawing maps, doing oops tickets, locating all the lines for building that's going on. We can be TV cameraing out in the wastewater system, cleaning the collections lines, cleaning the lift stations, doing electric to the lift stations, working on the radio transmission units that communicate from the lift stations to the wastewater plant, and then the actual wastewater plant. Anywhere from mowing to cleaning to electric to plumbing. Really, a wastewater operator has to be a jack of all trades. And when we talk about being a jack of all trades, maintenance can be a reactive thing or it can be a proactive thing. It can be something where we proactively change the filters in a blower so that the blower has adequate um, airflow to it. Or it can be reactive. When the blower shuts down, we go in, well, it got too hot. Why did it get too hot? Well, the filters are clogged. We really want to be on the proactive side, the plan side of the maintenance. I've worked doing both. I've done reactive maintenance and proactive. And as an operator, proactive, it feels better. When we do that type of proactive maintenance, one thing that we need to always be considering is looking ahead to the future. And so when you talk to your supervisor, you know, we always want to be budgeting for next year's cost. So if you have to rebuild a clarifier, redo a cabinet, um, any of those big, maybe not a cabinet, but like a clarifier, redoing the buying new influent pump. Some of our influence pumps can cost anywhere from eight to $100,000 and up. So we need to always be thinking about the future and have a plan and some facts and figures for when the administration comes to us that we can be good operators. There's all types of uh, monitoring that we can do. We can vibration monitoring. Are we seeing changes in equipment vibrations such as a bearing decay, a drive belt wear, misalignment or rotating of shafts? We can do thermal imaging. We can shoot our motor, see what kind of uh, what are the bearings? What were the bearings a year ago? What temperature are they getting higher? Knowing those key components can also help us when to suspect when a piece of equipment is going to break down. We have corrosion. So corrosion is the gradual decomposition or destruction of a material by chemical action, often due by an electromechanical reaction. Corrosion may be caused by stray current, electrolysis, galvanic corrosion caused by dissimilar metals. In a wastewater plant, we deal with water and we deal with metal and we deal with electricity. So you're always going to have corrosion. Oil analysis. Sometimes one of your pumps you can send out to have the oil analyzed to see maybe if you can extend when your oil changes more. If that oil is not breaking down, possibly We don't have to change oil as frequent, which just saves the city money, or the municipality, or village or state organization, whatever you work for. Amperage draw. Having a good amp meter, and if you're qualified, measuring the amps of each leg of a pump or motor will tell you how hard that pump and motor are working. If you have any problem and the operators come to you and say, well, the pump is not pumping, being able to amp each leg and tell what kind of amperage draw, you know, if it's um, if it's clogged or partially clogged, or something stuck in the ear, wear ring, your amperage is going to go sky high. Collection system maintenance. On page 575, we're in a new era. Pretty much a lot of your organizations have gone away from a map and they're to a computer-based system, which is so much better, I find. A GIS system, and if you don't have that, try to get that, because gone are the days where hopefully I tell a guy, I think that manhole's over there behind that one tree in between the road and the bridge. Those days were very cumbersome and cost a lot of time. But with the GIS, and if you keep it updated, you can keep a good record of your repairs that you have out in the collection systems, or trouble spots that may need lined or cleaned periodically throughout the your lifetime of working there. On the bottom is a remote control camera that drives through the collection system. We want to make sure that our collection system is passable by solids and water. Nothing worse than getting a call and going out to a resident's house and sewage overflowing outside their house because they're hydraulically different than another house. I've been there, I've done that, and doing camera work tells you what your infrastructure is doing. We tend to forget about the pipes that are underneath the ground. We see the roads and the parks and the buildings, but we really need to be advocates for our collection system, and being able to show root intrusions and sags, debris in the collection systems with video evidence to support when we need monies allocated for our collection system. Computer maintenance management system. I used to keep everything on a computer, or on a paper form. And when I did that, it was good, but I really my maintenance really came a lot cleaner and more organized when I went to a computer system. So every time I put a pump in, service a pump, service a mower, I can put notes in there, I can put pictures, and whoever comes after me will be able to access that information. And so what it does is it takes file cabinets that were full of papers and puts it at the fingertips of someone. We want to always be leaving the job to someone better than when we left it. We work on disinfection systems on 591. We UV systems. They they deal with ballasts, the LCAs, the DCAs. They all talk to each other, like the send signals to the ballast. The ballast lights the lamp, and the lamp is in the sleeve, which is in the water. Anything can happen. It could be an LCA, it could be a DCA, it could be a bad bulb, a bad transformer. You know, Disinfection systems take a lot of maintenance to keep up. If you're dealing with gas and uh, dechlorination, once again, those pumps can go bad, they can lose prime. So there is a lot of maintenance that we do on the disinfection system. If you do have a chlorine leak on page 592, ammonia water will detect a chlorine leak. Use a concentrated ammonia solution containing 20 8 to 30% ammonia. Um, small piece of cloth soaked with ammonia water wrapped around the end of a short stick makes a good leak indicator. Wave the stick in the general area of the suspected leak, but do not touch the equipment. A white cloud of ammonia chloride will form if there is a leak. So that's one way that you can detect a leak in your chlorine system. Plant tanks and channels. Every channel and tank should be cleaned. Digesters, they should be every 5 years. Your aeration tanks, I would suggest somewhere around there, but we need to get down in there and see what's going on. Are bolts getting corroded? Are diffusers getting clogged? How much debris do we have in there? We really need to be proactive in that. Building maintenance, changing out light bulbs, cleaning. I'm a big fan of cleaning, keeping things organized. The plant's grounds, usually at wastewater facilities, there's a lot of mowing and a lot of weed eating. And so keeping your plant uh, immaculate will help public perception. Maybe you have a repair shop. Some of the bigger cities have pump repair shops. We do not. We have to send our pumps out. Let's talk about lockout tagout procedures. We want to isolate any energy device or anything that can harm us, whether that be hydraulically, electrically. We want to lock it out and tag it. And you can see on page 597 is a operator working on this line tag. We want to lock it out because we want to go home safe. And so, most likely on one of your test questions, there will be an answers about lockout, tagout, emergencies. As operators, perhaps we want to invite the uh, fire, fire and EMS down so they can get a lay of the land in case something happens. They're specially trained in confined space and also in excavation rescue. So also knowing, a Chemtrec number in case of emergency of chlorine, having a SOP, a standard operating procedure for each disaster that possibly could happen is important. Electricity, as an operator, you may work a lot on electricity and you may work on non-electricity, especially if like your union, maybe you have just a electrician and that's all he does. But understanding electricity is important. It's important because it's on the test, but it's also important just to know how it works, the basics, and how to be safe around it. So, we have nameplates. A nameplate is a durable metal plate found on equipment. It lists the critical information, how many volts it is, how many amps, who makes it, the serial number, and the model. So that if that piece of equipment breaks down, you can put that model into the internet or your manufacturing rep and order another piece of part. So usually in the wastewater system, we have alternating current. That's kind of your household current. And then your direct current, which is very similar to your car battery. And we use both of those. We use low voltage AC and DC voltage for controls usually. We don't like to use high amperage for the controls. One, there's no need for it, but two, it's a protection. So you can have single phase power like on 603. So single phase power is fine in our lighting systems, small pumps like a sump pump, motors, various power tools, and those are 120, sometimes 240. Single phase means that only one phase of power is supplied to the main electrical panel at 240 volts and has three wires or leads. So two of these leads have 120 each. The other lead is neutral and usually coated white. Then you have your 480, your 440, and your 550. That's your three-phase power. And That's for operating your pumps. On a three-phase system, if your pump is ever spinning backwards, you just flip one of the legs with the other leg and it will go in the right direction. So that alternating current electric on three-phase has a certain rotation to it. They make rotation meters that you can make sure that your pump and all your equipment is rotating right. You want to, your generators, when you pull out a portable generator to run a lift station in the event of emergency, you want to make sure that it's on the right rotation. Meters and testing. So you'll need a multimeter if you're going to do any kind of work with it. You need a multimeter. I recommend the one that's pictured on either side. Having both of those would not be a bad. The one to the right is actually a clamp meter. So you would clamp that around a wire, and that would measure your amps. And so as the pump is working harder, it's going to pull more amps. The digital multimeter right there cannot do it, but some that even Fluke makes can be used as a megameter, and we'll talk about that later. In the 609 is a voltage tick. I call it a wiki. That's my personal name. It's a non-contact where you just have to get close to it, and if it lights up, there is voltage there. It's a quick and dirty way to double check to make sure that there's power that's off. You can find them for about $20. I highly recommend that um, you get one of those to test electricity. But a meter is, testing it multiple ways, even with a meter, is good. A megger is a device on 614. A megger is a device used for checking the insulation resistance on motors, feeders, bus bars, grounds, branch circuits, wiring, called megging. So what we do is we would put one of those legs on the ground and one on one of the wires going down to the pump. We would send, 550 volts through it, and we're measuring the volts as they come back. If they get lost, you'll have a lower amperage reading, and that means that somehow you're losing that voltage or it's going to ground. So a megameter is invaluable for, you know, water and wastewater. We've talked about partial flume. Partial flume is an open channel flow measuring developed. A partial flume consists of an inlet that converges to a short, narrow throat section before discharging into a diverging section and expands downstream of the throat. The level of the liquid passing through the throat section is proportional to the velocity, which can be used to estimate the flow rate. So you might have to keep one of those clean, maybe get the algae off of it. One important thing is it's widely used and it requires a little bit of maintenance. So we've talked about some of the other flow meters and other lessons that I've done. Sensor maintenance, obviously sensors can go bad. You need to calibrate them, cross check those, do whatever the manufacturing requirements are. With wiring, periodically going back through, shutting the power off, and tightening all the loose contacts is not a bad idea because as they age and they get heat and they work loose with all the electricity, they can become loose. When we talk about protection of electricity, fuses are electrical devices that have open circuits when the current flowing through them exceeds the rating of the fuse. So a fuse will bust and you'll have to replace it. Um, Always having the right fuse, never replacing a fuse with a different fuse that doesn't work for that application. Always having the right fuse and having backup fuse is invaluable for an operator, but a fuse can protect your equipment so that, we're only wasting $20 instead of maybe $80,000. Circuit breakers. Circuit breakers are very similar to what's in your house. They can be reset, but I will warn you, if they keep tripping, there's a reason why it trips, and so they provide a protection from excessive current. to equipment. And the nice thing is you can reset them and you don't have to replace them all the time. Just knowing ground. Ground is an expression representing an electrical connection to the earth or a large conductor that is earth potential or neutral voltage. Motor frames and all electrical equipment and equipment closures should be connected to ground. The third prong on cords from the electric hand tool is the equipment ground and must never be removed. We want to be protective of ourselves and other people. So let's always ground our equipment, ground our tools, make sure we're using, if we're using water in or using a piece of equipment in a place that has water, we're connected it to a GFCI. SCADA system. Sometimes SCADA system, you will be called out as a maintenance man to fix the SCADA system. We have a lot of PLCs that talk to the main SCADA system in the office, and so figuring out why a PLC is not talking to another PLC is important. You can see a programmable logic controller on 634. So this is the main head that talks to one of the SCADA systems, and it seems overwhelming, but knowing that there's inputs and outputs and they're using computer signals to talk to those cards, what they call cards, and then controlling bigger pieces of equipment with those inputs and outputs. We've talked about records, but records of electric is super duper important. We talk about motors. 637 is your typical motor. You can have single phase, three-phase motors. Always, keeping them uh, greased if they need grease. Do they have purge points where you can purge the grease, or are they seal bearings? Knowing the type of bearings, talking to the manufacturer before you start is imperative. On 639, you can see a nameplate. So that will be on every motor. And, it will have the model number, the type, the serial number, the amperage, the volts, revolutions per minute, the duty. All that gives the operator and the maintenance man a good indication of what it needs to um, be delivered. We use starters. So starters is a device or group of devices usually used to connect electrical power to a motor. So on 644 is a motor starter, and we'll use 120 or some other to use that starter to come together. So when it gets a 120 signal or a normally open or normally closed signal, it it connects the starter. The starter, you'll hear a click, and when that starter comes together, then it will operate the motor. So we're using low voltage to start and stop a motor, and that low voltage could be from a hand off switch, or can also be from a SCADA system. Variable frequency drives on page 647. So on variable frequency drives, it'll speed up and slow down the motor. So if you want to keep a wet well at a certain level, a variable frequency drive will speed up as the flow speeds up, and then will decrease as the flow decreases. They save on pump wear because it is not starting and stopping the pump, and it's a great way to maximize your pump life. Alignment, as you put in blowers, changing alignment, fixing the alignment. If something's out of a line, it's going to cause more stress. So you need a straight line, a level, a plumb bob, all those things we use as maintenance often to make sure everything is aligned. Troubleshooting, you will troubleshoot, and some things you will get good at, and some things you will not. But types of pumps, so positive displacement pump, like I've said before, is like a piston in a cylinder, and every time it it goes in and out, it's like mm, a piston in a car, and that's positive displacement. So every time it's going to go. You cannot close the discharge on a positive displacement pump because it'll cause rupture. Centrifugal pumps use the centrifuge effect, and total suction lift should not exceed 15 feet. And they're the most common types of pumps that are used in wastewater are centrifugals. You can see on page 660, you can see a centrifugal pump, the eye of the water. You can see the rotation. So on the bottom, it's important to see uh, the correct rotation of the pump. You never want to airlock your pump. Your pump uh, or piping can get airlocked, and you never want to get those airlocked where you get a thing of air in it. You also never want to cavitate your pump. Cavitating is when it's getting air pockets are collapsing on the impeller of the pump. That'll cause problems for your pumps. We're going to go over to page 672. That's an inline screw pump. Um, I've seen these that bring in influent. You can see a big picture of them in point 5.72. So let's talk about pump seals. Wastewater utilities have several choices when selecting materials to guard against excessive pump leakage. The most common sealing material are packing. So packing is that Teflon or graphite or other braided material used to lubricate and minimize leakage around the rotating shaft and prevent air from entering in the suction pump. So you can have uh, pumping or packing, but then the other ones that you can have are mechanical seals. So on page 680, many pumps use mechanical seal instead of packing. Mechanical seals serve as the same purpose as packing to prevent leakage between the staff, pumping casing and shaft. Like packing, they are located in the stuffing box where the shaft goes through the loop. However, they should not leak. Um, they are more expensive than packing. They have a high initial cost. If they fail, the pump must be shut down. And so a lot of people are going more towards the mechanical seals. And you can see a picture of a mechanical seal on 681. Lubrication, scheduling, and storage. Inside those pumps are oil, and those periodically have to change. All your blowers typically have oil. All your motors will have grease zerks. Your equipment, your tractors, your gators, your lawnmowers, they all have grease zerks. And having a regular schedule time where you grease those are important because if not, you will have failure. Common types of bearing failure. If you don't grease, you don't have those. You're gonna have fatigue failure, contamination, Bernelling, false Bernelling. Belt drives, replacing your belts before they shear is important because it could ruin something if it throws a belt, just like your timing belt in your car. Shear pins are allowed. They're like a sacrificial pin that should shear with too much stress or bind. A lot of wastewater systems have air separation systems where the water is air gap separated from the plant. And the reason why we have that is because we do not want any contamination. And so having that physical air gap separation between any wastewater pump and your potable water system is important because that's the only sheer way to make sure that you're not having cross contamination. Check valves are another way. In your plant, you will have multiple check valves. Check valves operate one way, and so as the flow goes through, it cannot go back because the valve shuts. We have several different valves in our sewage treatment plant. So gate valves are used to isolate pumps from the suction and discharge piping so that they can be safely disassembled and the service. Gate valves have a disc or wedge that is lowered the through the valve body with a hand wheel uh, or crank. So on page 695, you can see a gate valve. They do also do um, do require maintenance. Plug valves. Plug valves are used to isolate and discharge suction lines. They're frequently used with wastewater systems that have higher solids content, such as sludge pumping systems. Sluice gates are used extensively by wastewater to isolate the direction of flow between channels, tanks, and processes. You usually see these sluice gates in your influent building or perhaps one of your aeration tanks. You'll see sluice gates. Talked about centrifugal pumps. No type total dynamic head. Total dynamic head is when a pump is lifting or pumping water the vertical distance of the elevation of the energy line or the suction side of the pump to the elevation of the energy line on the discharge of the pump. So your total dynamic head, how much head is on your pump, knowing because uh, having too much head could explain why a pump is not operating as it should. A lot of systems use pneumatical air treatment systems, compressors, just knowing to change oil, uh, also making sure that there's not water in the air. Unplugging pipelines, with collection system, you can use rodding tools like in 711, you can see the picture, or a high velocity pressure unit. So like your jet rodders, your jet trucks will have a hose on the front and will send it down the collection pipe with high pressure, and that's used to break apart any kind of debris that's in the lines. Once that debris is broken apart, then they'll send the vac tube down and suck out that debris. If you're a smaller facility, you're not going to have one of those. This is a picture on 712 of a guy using a small high pressure hydraulic unit. That's for those little pipes that you have around the plant. Well, that is the end of chapter 5 for maintenance. I appreciate it. Thank you.